All right, dividing decimals. So the first thing we want to do is review the three ways of writing a division. So the number that's being divided either goes on top of the fraction, that's 1 divided by 8. So that can either be written as 1 divided by 8 or 8 divided into 1. So we're going to rewrite this fraction as a division, and you might be freaking out thinking 8 doesn't go into 1. So let's review another topic from the last section. So first of all, remember that all whole numbers have a decimal point at the end, and then after the decimal point, you can add as many zeros as you wish. We talked about equivalent decimals. So all of these are the same number. So let's use this to help us solve this. So if we wanted to write 1/8 as a decimal, that's the same thing as 8 divided into 1. And that 1 can be written as 1.0 because it's a whole number, the decimal point's at the end, and you can add as many zeros as you want. Now we're going to move that decimal point up here, and then we're dividing. Does 8 go into 1? No, it goes in 0 times. So then we go over, does 8 go into 10? And that's a yes. It goes in 1 time. 1 times 8 is 8. Subtract, and we get 2. And remember, you can add as many zeros as you want after the decimal point. So I'm going to add another 0. I can bring that down. And then does 8 go into 20? The answer is yes. It goes in 2 times. 8 times 2 is 16. Subtract. And then you can add as many zeros as you want. This could go on forever. 8 goes into 40 exactly 5 times. So 1/8 is the same thing as 0.125. All right, let's try another example. Let's write 3/8 as a decimal. So this would be a good time to hit the pause button and try this one on your own. Okay, so the first thing you do is write this as a division, and the number that's on top is the one that goes on the inside. And you say, oh, 8 does not go into 3, so I can add a dot at the end, and then a 0. And then how many times does 8 go into 30? That's 3 whole times. 3 times 8 is 24. Subtract, and you get 6. You can add another 0. 8 goes into 60 7 times. Subtract, and we get a 4. And you can add another 0. Remember, you can add as many zeros as you want. So 3/8 is equal to 0.375. All right, there's 3 stopping rules. And the first stopping rule is this one. If your remainder is 0, then you can stop. Let's do another example. All right, let's write 2/3 as a decimal. And if you want, you can hit pause and try this one on your own first. Right, so the first thing you need to remember is that the number on top is the one that goes on the inside. And then 3 does not go into 2, so we can add a decimal point. And when you add the decimal point, be sure and put it in the top. So 3 goes into 2 0 times. So then you add a 0. 3 goes into 20 6 times. 6 times 3 is 18. Subtract. And we get a 2. You can add another 0. 3 goes into 20 6 times. Subtract. You get 2. By now you might be getting a feeling of deja vu, like I've been here before. And you probably know what's going to happen. It's just going to keep repeating. So that's the second stopping rule. If you can see that it repeats, then you stop. So you could write 0.666 forever, or you could write ... But the cool way to write it is to put what's called a repeater bar over the first number that gets repeated. So that's the official way to write a repeating decimal. All right, let's try another one. All right, let's write 17/11 as a decimal. So, oh yeah, and hit the pause button and try this one on your own first. Okay, so the first thing you need to remember is that the number that's on top is the one that goes on the inside. And then you go, oh, that goes in one whole time. All right, and if I want to continue, now I can add a dot and then a 0. So 11 goes into 60 5 times. And we subtract and get a 5. We can add another 0. That goes in 4 times. And we subtract and we get a 6. And you can add another 0. And that goes in 5 times. Subtract, you get a 5. Add another 0. And that goes in 4 times. All right, and now you start to see the pattern. So it's not necessarily just going to be one number that repeats. It could be 2 or more numbers. So you write this as 1.5454 forever. Or the official way to do it is to use the repeater bar, and you're going to put the repeater bar over the first repeated decimals. So it's going to be 1.54 with the repeater bar over the 5 and the 4. All right, so these are 2 examples of the second stopping rule. If your decimal repeats, then you're going to stop. All right, let's do another example. All right, let's write 22/7 as a decimal. And again, you can hit the pause button and try this one on your own. All right, so you need to remember that the number that's on top is the one that goes on the inside. So 7 goes into 22 3 times. And now, if I want to add zeros, I have to put my decimal point, and then you can add as many zeros as you wish. So 7 goes into 10 1 time, subtract, and we get 3, add another 0, it goes in 4 times, add another 0, it goes in 2 times, and then you just keep adding zeros. All right, this is the third stopping rule. If it never ends and never repeats, you want to stop. All right, most of the time you'll have already decided how many decimal places you want your answer to be. Let's round off at the hundredths place. And remember, the hundredths place is right here. So that's tenths, hundredths. And if I want to round it off at the hundredths place, I need to divide to one more place so that I can tell whether it goes up or stays the same. So to round off at the hundredths place, you divide to the thousandths place. And since the thousandths place is 4 or lower, then the hundredths place stays the same. So you could say 22 over 7. And I'm going to use the approximately equal sign to let me know that's an estimate. So it's 3.14. If I wanted to know the answer to the 10,000ths place, I would divide to the 100,000ths place. All right. All right, let's try another example. Write 11 over 7 as a decimal. Round off to the hundredths place. So this would be a good time to hit the pause button and try this one on your own. All right, so we'll put the 11 on the inside. 7 goes into 11 one time. Subtract, and we get 4. If I want to add zeros, I have to put that decimal point first. So 7 goes into 40 5 times. I can stop and say, have I gone far enough? Well, the 5 is in the tenths place, so no. So we subtract, and we get 5. Add another 0. That goes in 7 times. So the 7 is in the hundredths place, and the question is, can I stop now? And the answer is no, because in order to round to the hundredths place, I need to divide to one more place. So we subtract, I get a 1. That goes in 1 time. All right, so I've divided to the thousandths place. So now I can round to the hundredths place. Because the thousandths place is 4 or lower, then the hundredths place stays the same. So you could say 11 over 7 is approximately equal to 1.57. Okay, so now we know how to divide whole numbers and get a decimal answer. What do you do if you start with decimals? So I'll show you the y first, and then we'll do the shortcut. So if you have 0.03 divided by 0.04, that's the same thing as 3 over 100 divided by 4 over 100. And remember that when you divide by a fraction, you multiply by the reciprocal. Well, 100 over 100 is equal to 1. So that's the same as 3 over 4. So 0.04 divided into 0.03 becomes the same problem as 4 divided into 3. And this part where we canceled the 100 is as if we moved those decimal points the same number of places. Now 4 divided into 3, the dot's there. How many times does 4 go into 30? 7 times. How many times does 4 go into 20? 5 times. So 0.03 divided by 0.04 is 0.75. Let's do another one. All right, let's look at 0.0007 divided by 0.02. So if we wrote that as a fraction, that would be 7 over 10,000 divided by 2 over 100, which is 7 over 10,000 times 100 over 2. So we could cancel 10, cancel 100. That's the problem. That's the same problem as 7 over 100 times 1 over 2. So basically, if you have 0.02 divided into 0.0007, that becomes the same problem as 2 divided into 0.07. So when we canceled 10 and canceled 100, that had the same result as moving this decimal 2 places and this one 2 places. How do we finish this problem? Well, wherever your decimal point is, you move it to the top. And then does 2 go into 0? No. Does 2 go into 0? No. Does 2 go into 7? That would be yes. And then subtract. Then you can add a 0. 2 goes into 10 5 times. And that goes in evenly, so then we can stop. All right, so what's the shortcut? Let's look at our 2 problems. So in both of these examples, we move the decimal point to the right the same number of times. And that's basically this idea of canceling multiples of 100. And here, we only had to move it 2 times. So your goal is to make your divisor into a whole number. All right, let's write that down. Let's look at this example. We have 0.005 divided by 0.02. So that's 0.02 divided into 0.005. So the shortcut is, instead of writing out those fractions and canceling, we're going to move the decimal point on both numbers the same number of times. And how many times will we move it? Do we move it 2 times or 3 times? Well, the answer is we're going to move it until the divisor is a whole number, and then the number that's getting divided basically just goes along for the ride. So we have to move it the same number of places. This is like canceling 10, canceling 100, until the divisor is a whole number. And it's definitely worth it to rewrite the problem. So let me write down this step. So we're going to move the decimal point to the right in both numbers, the same number of places, until the divisor is a whole number. The number that's getting divided does not have to be a whole number. All right, then you move your decimal point up. You say, does 2 go into 5? That goes in 2 times. You can add as many zeros as you like. That goes in 5 times. And there's your answer, 0.25. Let's try another one. All right, let's try dividing 0.001 by 0.03. This would be a good time to hit the pause and try it on your own. All right, so this is 0.03 divided into 0.001. And you ask yourself, how many times do I need to move the decimal point? And the answer is only 2, because the divisor needs to be a whole number. The number that's getting divided just goes along for the ride. So we have 3 divided into 0.1. And because I'm done moving the decimal point, I'm just going to put it up top. Does 3 go into 0? No. Does 3 go into 1? No. So I can add a 0. Does 3 go into 10? That would be 3 times. 3 times 3 is 9. Subtract and get a 1. Add another 0. 3 goes into 10 3 times. 3 times 3 is 9. I'm probably starting to get deja vu. All right, so this is our second stopping rule. It's a repeating decimal. So the answer is 0.0333, etc. So the repeater bar goes over the first number that gets repeated. It doesn't go over the 0 because there's only one of those. It goes over the 3. All right, let's try another one. All right, let's try dividing 4.8 by 0.02. So this would be a good time to hit the pause button and try it on your own. All right, so we got 0.02 divided into 4.8. So we're going to move the decimal point on both numbers until the divisor is a whole number. So if I move this one 2 times, I have to also move this one 2 times. And you're thinking there's nothing there. So I'm just going to fill in with a 0. So now that's 2 divided into 480. And you can go ahead and put the dot just in case you need it later. 2 goes into 4 twice. Bring down the 8. 2 goes into 8 4 times. And then we're not done. Got to bring down the 0. 2 goes into 0 0 times. All right, let's do a word problem example. If you bought 4 pounds of cheese for $33, what is the price per pound? So because we have the word per relating the dollars and the pounds, you know it's a rate problem. So that rate is dollars per pound. So let's write the rate equation. Dollars per pound times the number of pounds is the total number of dollars. So I know the total number of pounds. I know the total number of dollars. I'm looking for the price per pound. So this is a missing factor, so we need to divide the product. So 4 goes into 33 8 times. 8 times 4 is 32. I want to keep going, so I'm going to add a decimal point at the end. I'm going to move it up here, and then you can add a 0. Bring that down. 4 goes into 10 2 times. 2 times 4 is 8. I can add another 0. 4 goes into 20 5 times. So the price is $8.25 per pound. Right, if my monthly income is $5,000 and my rent is $3,000, what decimal of my income is rent? So this is a translation problem, similar to the ones we did where we were looking for the fraction of a number. So it's basically the same, only now we're looking for the decimal. So of means multiply, is means equals. So I'm looking for the decimal. My income is 5,000, and then the rent is 3,000. Let me rewrite that so it looks a little better. So I have a missing factor, so we're going to divide the product. So that's 5,000 divided into 3,000. 3,000 is too small, so I'm going to add a decimal. Then I can add a 0, and that goes in exactly 6 times. So the answer is 0.6. And you've probably never heard someone ask for the decimal, and that's okay. For now, we're looking for the decimal, but we're going to use this in the next chapter when we're looking for the percent. So you're going to get this decimal answer and then convert it into a percent. But we'll wait until next chapter for that.